Welcome to Layered Insights, a 3D printing podcast for a pop-up episode of FormNext 2025. I'm Alex,
I'm Matt.
and we're here to talk 3D printing. Matt, what's going on, buddy?
Not too much, working a lot, but FormNext is always an exciting thing to watch while I'm doing other things and see what's new, what I'm gonna buy maybe in the future to help
Yeah,
with my business.
totally. So let's for anyone that doesn't know what FormNext is, can you give like a few words on what it is?
Yeah, I don't know too much about it. It's
That's okay,
always
me
takes.
either. I was gonna just add on to whatever you said. Here, let me
I'm pretty
pull it up
sure
and we
it
can
always
just
takes
read it.
place in Frankfurt, Germany every year. It's one of the biggest. I think it is the. I mean, it competes with Rapid TCT, but I think it is the biggest 3D printing convention or additive manufacturing convention in the world.
Yeah, and
Um,
this is one of the shows that if you work at a 3D printing company, like, you would be excited to get on the list that goes to these events, like,
yes,
it's the trade shows to go to
it's
in the industry.
multiple floors of companies ranging from industrial stuff to even hobbyist level printers, so like the Bamboo Lab with the Prusas and stuff. So you'll see a wide range of companies and industries and types of printers too.
And I got the website open here. It says, "FormNext, the industry hub for additive manufacturing." As hub for additive manufacturing, FormNext is central information platform for industrial 3D printing experts and production professionals from a wide range of application engineers. With the trade show in Frankfurt, up to date industry information and networking opportunities 365 days a year, we bundle expertise, create in depth professional exchange, and access to the local AM solutions. Which, yeah, that's kind of it. Um, and it's interesting because one thing, I don't know if we've touched on this, but it's something that gets brought up a lot. Europe, in a lot of ways, is 5 to 8 years ahead of the US in their
Yeah,
understanding of additive. So, having it in Germany, in, the EU, that's a, um you're gonna meet some of the most intelligent people that have spent the most amount of time thinking about making parts with additives. So, it's a who's who of the people on, the ground that are doing it.
Europe is also big on all of the material advancements too.
Mm. Yeah, what could you dive more into that as, like, the material guy?
Yeah, besides China, a lot of the more innovative materials or engineering grade materials are actually being developed in Europe.
Mm,
You can actually, I don't, I'd almost say there's more people in Europe making filament than in the United States.
mm.
There's a lot in the UK. There's a lot even in the greater part of Europe.
Yeah, and, I mean, I would say probably a lot of our machines, aside from China, um, are coming from, the EU, like, the Czech Republic with,
Yeah,
you've got
Prusa.
Prusa and, um, which had a very, very big week at Formnext, which I'm sure we'll get into.
A
But
lot of
yeah.
the people that are designing parts for
Mm,
3D printers, like the nozzles or the extruders,
yep.
all that stuff. A lot of those are European companies.
Yeah. Yeah, it's really it's a fun group of people. If you're into 3D printing, like, going over there to a show like that is uh, phew, a spinal tap of great
It's a
information.
real treat.
It's
Yeah.
yeah, yeah. But regardless, what we wanted to do, so we're off season, we're between season 1 and season 2, which congratulations, Matt. We completed our first season. What did you think about, just real quick, about finishing and getting your first season of a podcast down?
Uh, it was interesting. It's interesting listening to them back and hearing myself and watching myself. But
Yes.
uh, right, it's a tool I'm still honing, right? The whole
Mm,
podcasting thing. So hopefully I'll get better at talking. If you've noticed, I've upgraded my camera and my microphone. So
yep.
hopefully when we show parts now, they look a lot better.
Yeah.
Um, but no,
I
I'm excited to do season two, and
Mhm.
we're gonna do interviews and talk to other people. So it's
Yep.
a great learning experience altogether.
Yeah, and if anyone wants to come on and talk about 3D printing, whether you're a small maker, right? You just started, but you want to get on and talk about stuff, to the people making the printers, to anyone making filament, just making amazing stuff, designing cool stuff, or maybe you just work in the industry, and this would be a good place to jump on and kind of flex your expertise and join in the conversation. All of that is possible and more. So feel free to reach out
And
to us.
I know both of us, we regard this as like our 3D printing therapy, right?
Oh
This is our
yes.
therapy session for all the all the trouble and the everything we go through with the 3D printing.
Yes. So if you're into 3D printing or work in the 3D printing industry and you need help,
That's our
uh,
pitch.
yeah, yeah, that's our pitch. That's our 3D Printers Anonymous group. So feel free to join in. Okay, so because we're between and FormNext is such a big show, we figured we would just jump on and talk about some of the stuff we've been following. Matt's been busy. You've been 3D printing stuff. I've been off writing the book and developing some AI tools. So like it's just been nonstop uh, stuff going on in the background, but can't miss FormNext. So I'll leave it to you, Matt. What's the first thing that you would like to bring up
I don't know if we
from
want to start
FormNext?
with uh I'd say the big thing this year, at least in the more consumer level market,
Mm-hmm.
is multi-material tool changing,
Yep.
however you want to brand it, right?
Mm-hmm.
So like Bamboo Lab released their H2C, Prusa released their partnership with for Index. I think that's how they're pronouncing it.
Yeah, I think so. INDX in all caps.
INDX,
Mm-hmm.
which actually stands for something else that you rather than what you think it would be.
That's
Right,
funny.
not to be confused with Index,
Mm-hmm.
which is INDEX, which is usually two print heads on the same gantry, right?
Yep.
INDX actually stands for inductive something else. I forget what the DX stands for.
Mm.
So it's don't confuse it with INDEX
That is good advice.
because that's completely different. So yeah, so both of them, actually both systems are swapping nozzles instead
Yes.
of either doing material swaps or changing with a whole, picking up a whole new tool head.
Oh, I've got a video for that. Let me pull that up. And that's a huge difference. I mean, so we've been in this long enough where the like having the E3D V6 was a big change. Having that
Hmm.
small block that you were able to change out, like that was a big deal back in the day. And then the Revo came out and things like that that have made the same solution easier.
Yep.
But to your point, the nozzle, like how big of a change is that for people? Because it's different, right?
I mean, it's completely different. I mean, it's so different that the software has not caught up at all.
Yeah. Yes.
The software, the
Great point.
firmware, we're we're so far behind on that for
Yeah.
for these types of systems. Like when you're talking about, oh, we can do sure we can do multiple material, we have the software and slicers to do that. But now we're talking even on the Prusa XL, it's not available yet, right?
Right.
I could have multiple nozzles with multiple different diameters. Right now, there's no way to integrate that into a print,
Right.
which could be a big time saving cost for certain prints. Like you could do, a different size for the supports or a different size for the
Hmm.
outside or inside. And now that, we're talking about more than five, we're talking about, eight on some of these systems.
Yeah.
You could do, and it's so quick. You could utilize that even though you're maybe doing more tool changes, changing to a different size nozzle for certain parts of it might speed it up, or if you
Hmm.
want to add more strength, there's so many possibilities that's just nowhere close to being integrated with the slicing software yet.
Yeah. And as someone that's been using like multicolor on the older style thing, right? The idler moving back and forth, one nozzle, like there is there's like an operational capability that comes with this too if you're like a 3D printing shop, especially with color, or if like you have a product line that requires certain materials, certain specifics. This machine can be set up with 8 to 10 of these materials, so your printer can spend even less time on like
Yes,
you as the operator can spend less time fiddling with stuff, moving things around, making sure that you remembered every single thing. Like the capability of the machine for a shop is like wild with this.
absolutely. Yeah, especially like, I mean, this is as a production house, right? This is kind of how I use my Bamboo AMS systems and my Prusa XL. I have multiple materials ready at my disposal. So I have to, like you said, worry about filling, go downstairs, make sure the right materials in there. I have stuff already ready.
Yep.
And then if I'm doing, all the same material, I could have multiple loaded. So when it finishes one spool, it just goes to the next one, right? So you get multiple capabilities out of having these multi tools, and you
Mhm.
just the printer's always ready at the disposal with different materials, and you can keep going when it runs out and stuff. There's so many different advantages from a production house that
Yeah.
make them very nice to have.
And the cool thing about this is that this was a partnership between 2 different companies, right? Prusa
Yeah, for Prusa. Yeah.
and Bondtech.
Yeah.
And so let's talk about, because this is definitely the thing I wanted to start with, but I didn't want to be the one to say it. So I'm glad you did. Um, but let's also talk about a little bit about the business side of things
Hmm.
too. Like in the 3D printing industry, to have 2 companies work together in tandem like this and deliver. So I think the kits were 4.99 and maybe 6.99 to get this upgraded on the Prusa. Um, that may seem like a lot of money, but when you think about the capability that we just talked about, all those advantages, that the hardware is being sold for that little
Yeah, it's not
is
bad at all.
is not bad, especially when the MMU upgrade was 299, I think, at one point for, the Mark
Well,
3S. Like,
even just compare it to the price of the Prusa XL, right?
mhm,
It's for 5 tool heads. I think it's about 4,000, almost $5,000.
yeah. And I mean, I need to, especially as I'm writing the book that I'm writing on 3D printing right now, like, this is such a cool moment that I did not see really coming, that I talked about in there. We've talked about on the podcast about this. Like, this is the age of these consumer level 3D printers, like Bamboo in the last age of 3D printing against all the Goliaths that existed in the
Hmm.
industry for the industrial side of things. Bamboo leveled the playing ground and got printers into more people's hands. Now Prusa,
Well, they
who
created that competition, right, for multi-material,
yep,
and everyone's like, okay, we got to figure out our own solution
yep,
because
and instead of rushing, instead
people took
of
their time. Yeah.
Prusa and Bondtech, they took their time. They both were working on great pieces of technology, and then they decided to bring together so that everyone wins. And the fact that
Yes.
this is available at 4.99 to start, right? It's under $1,000. They're already going to be offering it out there. They've clearly worked on it. They were able to show it off. I didn't see any posts about it not working or anything like that. Like, I also saw some speed tests
Hmm.
between, the
The
2 different.
comparisons. Yeah.
Yeah, so that was
Well,
really interesting, but the just to finish my thought, the message here is that this is what's gonna win in the world that we live in right now
in
for
the
3D
long
printing.
run. Yeah.
In the long run, it's not going after the quick, fast thrills or the big lottery ticket win in the 3D printing industry. It's gonna be about focused effort in making the
And
product great
innovation.
and innovating and investing longer term in the projects that you're doing and really finishing it, like really getting to the end of the line. Now, it's got to get deployed, they've got to ship it, it's got to work consistently. Like you said, the software, like it's going to be locked in their thing. So it's not going to be as
Yeah.
revolutionary out the gate, but you know that with the community that's behind Prusa, they've built
Or
up the
bamboo
trust,
too.
and
I think
Bamboo
either
too.
system.
Absolutely, and the amount of people now that exist before that multi-material,
Yeah.
like, race happened, There's so
Well,
much. So it commendation to the people in this photo, right? Who
yes.
like put the effort and the time and the trust and the investment longer term. Like this is just a big week for them, and
Well,
I think it's
I
awesome.
I I wanna harp back to the point you made about, you know, Prusa and, um, Bamboo Lab took the time to produce the next tool head or multi-material thing, right?
Yep.
So, before this, right, the main thing was AMS, bamboo-esque systems.
Yeah.
So, all the Chinese brands or yeah, I think there wasn't anyone outside the Chinese brands were all making their AMS-like system. Now that
Yeah.
AMS system, although they still have it, you can still swap out, and it's quicker because they have the extra nozzles and whatever, but
Mm,
still, the only AMS system without the tool changing, I'd say is I don't wanna say it's obsolete yet, but
right.
this is remarkably better, right? And now, like, why would anyone go buy one of these other Chinese companies, even though they also make good cheap printers, but
Right.
now they have the right? I'd say this AMS type system without the tool changing is now the old technology.
Yes, I do. I do. My gut is telling me not to jump that far yet, but I do with the
I agree.
excitement. Like that's what everyone should be
Yes.
leaving with in their mind, like from the show, whether they were there or whether they saw it online. I completely agree. That's the message that as long as
I
momentum keeps going forward,
yeah.
this fundamentally is better than the other
I'll
thing.
even give Snapmaker some credit here with their
Yeah.
Snapmaker U1. I think it's a $800 printer with 4 swapping tool heads like the XL, right? So
Yeah.
people are already before this, people are already proving you can make a good cheap
Right.
printer with, multiple tool heads or multiple nozzles, however you want,
Yeah.
it's all
Yeah.
similar-ish tech,
Well, no,
but
and you are right. Like the approach of 5 different filaments going into 1 nozzle, or 2
yeah,
even, like, that when both processes work perfectly, that is going to be the slower option, and there's gonna be more
it works
movement.
great
Yeah,
and the printer might print fast, but that
yeah,
switching
yeah.
adds so much time.
Yeah, yeah, I guess I wouldn't rule it out because 'cause we've seen many times, like, different formats of 3D printers, right? Like, oh, the
Mhm.
bed slingers, why would you
Yes.
ever change from the bed slinger? But then the Core XY comes back, and it's like, "Oh, no, we figured this out." So, I agree. I wonder my thing will be seeing how much groundwork you get with the nozzles, right? Like, how many
100%. It's
prints and hours
still
can you get
yet
there
to
before
be
the heater fails, before the
Mhm.
the grabber doesn't work?
It's still yet to
Um,
be fully proven.
totally, totally.
100%. I mean,
Yeah,
I'm still gonna be buying more Bamboo Lab X1 carbons because that's my main
they
production
work.
printer, and I'm gonna
Yeah,
be scaling up more anyways, and I'm not
right.
the ones I'm using on that, I'm not doing multicolor prints.
Yeah. I will say that the arbitrage here with that becoming a reality is that people that didn't want to afford the multi-filament changing systems like
Yeah.
Bamboo and the Prusa MMU, like you can now probably pick those up from eBay pretty good.
Yes.
Yeah. So
I
I knew you'd like that.
well, that's what right? I'm gonna be watching my Facebook Marketplace for the people getting rid of their X1 carbons at a cheap
Yep.
price and, right, like you said, the MMUs, people getting rid of their older systems.
Yeah. I wanted to zoom in on some of this stuff, which I thought was really cool.
And
So,
the
like
cool thing about the Bondtech too is, right, they're not Prusa, they're a third party company. So they're
mhm,
adapting this to other
mhm,
oh, you can buy it as a separate kit and adapt it to your printer.
right,
I
right,
think a
which is
lot
what
of
I'm
it was
planning to
actually
do
built
with my
out of
next
the
printer, yeah.
Voron community.
Mhm,
So you'll see a
yeah.
bunch of Vorons with this.
It's and I love that again, this goes back to and it's a lesson that I'm learning. I know we talk about it in our therapy sessions about being entrepreneurs and how much opportunity there is out there and
So
how
much.
it's so hard and it's that much more important for you to focus on the things that matter. I'm so glad that both these companies met in the middle and decided to do that because, like, if this was one company that tried to do this, they might have tried to push their own version of, the machine. Look how simply it fits into the Core XY frame. Like,
Yep.
I'm sure there's more to it, but they basically are just using one of the rails of this system. Like,
Part of the frame.
that's
It's part
all
of the
the imp
frame.
yeah, that's the
Yep.
only imp having done this from the inside, Matt, both of us in multiple different companies, like, the simplicity of
Oh
this
yeah.
is just it needs to be commended, like, it's you're just like, it's almost like, of course that's what it is, like, it's so good, you're like, "Y who didn't think of this?"
Hmm.
Yeah, that's good engineering, that's a good product for the industry that we're in.
Absolutely. The other things that I'm seeing that's related to this too is we're getting higher temperature higher temperature nozzles and higher the printers are
Mhm.
capable of going to higher temperatures on the nozzles, which means a lot more of these consumer grade printers can print engineering grade materials,
Yep,
which is great to see. So we're decreasing cost on, you know, everything for 3D printed parts.
yep,
And then the other amazing thing that no one's talking about is the actual heating technology for these nozzle changers.
go for it, jump in.
So I can't remember if Bamboo Lab is doing this too, but Bondtech is doing induction heating.
Mm,
So that's a there's another company, I think it was called Trident, that was making a tool head that was extremely expensive for inductive heating.
mhm,
Yeah, there you go. So, right, we're completely swapping the nozzle, and all the heating thing is inside the gantry,
mhm,
the tool head that sits on the gantry.
right,
So
which is the left
usually,
side, right? The Bondtech
yes.
yeah.
So usually, oh, I wish I had a, I do have one here somewhere, but you'd have right your normal hot end would have a chunk of metal,
Mhm,
right, to keep that mass of the heat up to the certain temperature. So you have because of that, you have a slightly heavier tool head, and then you have a cartridge in there heating up that block of metal. This does not have that. They're using inductive heating, so they have coils in there that only heat up the nozzle. It's super quick because there's less material, so you're not heat. There's less metal, so you're not heating up as much. So it's super quick. And that also, since you don't have that chunk of metal that you have to have as a heat reserve, the tool head's lighter.
mhm.
But that's not also the exciting thing for me. The exciting thing is that this heats up and cools down super fast, so that when you are printing and you go make a swap, you can fully cool it down. Almost,
Mm,
it cools down quickly um below the melting temperature of the material.
mhm,
That's how you're able to swap it and not have to do, spit out a bunch of material to prime it and stuff like that. They're still
mm,
doing the prime towers,
right,
but you're gonna get a lot less stringing. The material, the null, like the Prusa XL, the nozzle's not sitting there heating up beforehand,
mhm,
causing possible more material drip. And then since you can, I don't know if it'll use more power since you're continuously heating it. Probably not because you don't have to maintain as much temperature and it's a different
right,
technology.
that's a good point.
But the change is that you can change the temperature on the fly.
Mm,
So right now,
right,
when you're printing, you're like, okay, this is the only thing you can change, right?
right,
The first layer is 250 degrees, and then the rest of the print is 240 or whatever it is, right?
right,
And you can't really change temperature outside of that, right? There's no actively changing temperature when you're
right,
printing because of the technology. It would be too slow. You couldn't do it.
mhm,
This now you can change the temperature as you're printing,
mm,
which is amazing. And this is where they're behind on this. No one's integrating this into the slicer yet.
hmm,
So like you might want to do lower temperatures on the outside so the part looks better, higher temperatures
Right.
on the inside so you can print faster. And some of the stuff I've seen when I've been doing development with materials is that you want to there's a relationship. When you're printing, you have a relationship between your flow rate, obviously your speed, which is connected to flow rate, the temperature,
Mm,
all of that. Usually you can change that in the slicer.
right.
The one parameter you can't change is temperature. So
Yeah.
you're getting even, how the material's flowing is going to change with temperature, speed, how much you're pushing through it.
Right.
If you're pushing a lot through it, it's not always heating up all the way. There's
Mhm.
all these problems
Yep.
that can be solved with having a very quick adaptive heating system.
Mm,
So the, another thing I want to see integrated in the slicer is adaptive heating so that, oh, I'm going to start speeding up and pushing more material through the nozzle.
right.
Let's have that as a relationship to the temperature that I'm going to push through it at the same time. So then, your temperature should be a relationship between the amount of material pushing through and
Mm,
your width factor and all this stuff so that you should be able to get better quality parts and be actually utilizing more of the material science behind the polymers.
right.
I really want to see that integrated into the slicer. I'd love to see
Yeah.
that relationship between the temperature and all your other parameters and that changing on the fly.
Yeah, that's really cool. I mean, so
And stringing, right? So you could do
stringing.
retractions better too. If you
Yeah.
just cut the heat and then you turn it back on and it's quick enough for that.
That part of
We're
the
only even
process is yeah.
talking very low temperatures. You don't have to
Right.
change that much to stop stringing.
No. No, and, like, w we both do our fair share of, like, cavalier 3D printing, mid-print to save a job or something like that, and so having done that, I've seen how that actually reacts to the material, and you're right, like, that part of the process, that relationship between the temperature change and time, like, that is uncontrollable, and it's completely depends on your hot end, your
Hmm.
cooling fan setup, and the material that you're using, like and it's slow, right? It's like,
Yes.
if I in the middle of a print, I see stringing and I lower the temperature 8 degrees,
Hmm.
which is a lot, but let's just say I do it. It's gonna take the system 4 to 5 seconds before the sensors read that it bounced out, and it's probably gonna dip and then come
Yep.
back because the all that the you're pulling the filament through, so it's taking the heat out. Some of the stuff is cooling, and then as more stuff is coming out, it's all changing, and then it's gonna level out. So it's really like 8 seconds before the actual condition that you change the temperature for is active in the part. And you're saying that all those moments can be changed, with this much like with actual accuracy and precision
Yeah. And like the, um,
in
you
shorter
know,
time.
in shorter time and it being a relationship to other parameters.
Right.
So it's doing this in real time in relationship with how it's moving, how it's extruding.
Well, and a lot of that was like, and this is so I love that. And the thing that I was really shocked with was having worked with tool changing machines before and having thousands of hours in that
Yep.
process. Like, part of the problem with that is that the old way of doing things, a heater block, a nozzle, and a cooling section, like, it's heavy. No
Yep.
matter what you did with that setup, it is heavy. And that means that it's going to be holding heat more. So, like, if you got a really like fast printing head, you got the whole assembly of the connector down, it was still too massive and like could get you to the point where adding a fan was too much weight, so you might just be printing without a cooling fan. Like
Hmm.
that was the limit we were reaching with that approach. And to see how small form factor wise this has become is just I mean, it's a thing of beauty, and it must have been so many hours of toiling with this to get it down to what they did. Like,
And the price. They got
yeah, and the
inductive
price is
heating
down.
at a price that's good, because the other company that was making it was charging, you know, a decent amount of money for just a hot end.
Yes.
So they're bringing inductive heating to the mass market,
Yeah.
which
Yeah,
is
it's
a
a
big
totally
thing. Not
different
just that it's, single,
right?
changer tool head, but that's one of the biggest things with me. Now I just wanna see the software and the slicing catch up with
Totally.
what it can do with adaptive heating.
Totally. So, the it's so freaking cool. Like, the conviction that they have that this is the way that things should be in this solution, that they're gonna be the first,
Yeah.
they're gonna have that moment of being first, they'll be the most developed over time, but they're so convinced that they're gonna basically work with somebody who's gonna give it to the whole market. Like, that
Mhm.
is there just aren't let's just put it this way. I think it's a good sign of what the future of 3D printing is gonna be like in the industry, as opposed to what it's been like,
Mhm.
you know?
Or even look at it this way, this is ahead of the industrial market.
Yes, well, and this is where I see, most of this going, right? Is that
Yeah.
these eras flip. Like you're
Yes.
pointing out, right? The industrial had its big rise and it pulled a lot of talent from the commercial or hobbyist 3D printers at the time. Those people helped develop the industrial side of things, and then things started to slow down, and now we've got this is the rise of the next wave of 3D
Because
printing.
go look at the hot end that's on an industrial printer, and it looks ancient now.
It does look ancient now. Yeah. It's wild. It's wild, man. There was something else about this. I forget what it was, but I'm really excited to see where this goes. Oh, I remember. Okay. So here's where I think the next solution needs to come. So your point about the software. If we're going to have G code that is going to be instructed to the printer,
Yep.
the need it's a conundrum because that's going to be a larger file, just like the multicolor files were larger files.
Mhm.
With that kind of resolution per layer and technically per toolpath, um, the resolution of those 3D printing lines of code is going to increase, which is going to put us at this cross section where we are, where we're trying to find a smarter model, smarter 3D model, digital twin type thing.
Yeah.
But we have this thing called STLs that have been around forever, but they're just so simple and so light. You've
Yes.
got
It's
3MF,
only a
right?
mesh.
It's only a mesh. The 3MF, the G code, pure G code files, like, will we reach a point where some of these files are going to be too large, or we're kind of shoving it's the natural progress of things, but like the dam will
Yeah.
break, and then there's going
Well,
to need to be work done to optimize that.
I'm already seeing it because
Mm,
I have some large printers, and I'm sending the prints over Wi-Fi,
yeah,
and if I'm building a part that's, over 300 millimeters in size, I'm sending it over Wi-Fi. Sometimes it takes, like, I don't know, it could take 10 minutes depending how complicated the part
yeah,
is.
yeah.
So, but I think to your point, right? Back to the software, and if we're gonna be if the G code's gonna spit out all the code the printer
Mm,
needs and it's gonna follow, and we're all suddenly doing more stuff that integrate changing the heat, you have all these, changing heat commands in the code. It's it comes down to something I actually want. Maybe we'll do another episode about, and I might make a blog about, but having
sure.
uh dumb machines versus smart machines.
Yeah,
So right now with the dumb, for the most part, it's not completely, but for the most part, it's a dumb machine because all it's doing is following code from a G code, And
Right.
then sure, we have some AI stuff watching it, saying, "Oh, look, it messed up," or maybe
Mhm.
I crashed, and it'll just pause the code,
Yeah.
and then you'll go say, "Oh, okay, it looks fine now." Then it just starts the code again. So it's not doing anything from the sensors except stopping pre-done code.
Right.
So then we go to this all comes from my experience with robotics. So that's what we do. We'd have a dumb robot. It would just follow code. It would move here that much for, move for 5,000 milliseconds,
Right.
then turn one motor for 3,000 milliseconds, turn or whatever. It's dumb. Sure, it can be very, it can be very successful and it can do it continuously over and over again. But if something gets in the way or something
Mhm.
happens or something, the environment changes, all suddenly all your code's out the window. It's doing everything wrong, right?
Yeah.
So then in robotics, we were taught, okay, you have use of sensors. Add these sensors and then program to the sensors. So the robot kind of relatively knows where it is.
Right.
Okay, instead of I'm gonna move for 5,000 milliseconds at this speed with the motor, move until I see a wall, right?
Right.
Or if I'm picking up a cube, I'm gonna have a color sensor, make sure the cube is red, or make sure I grabbed it. All these things that's informing the next steps and telling the printer telling the robot how to run. So now I want to see this get integrated into the 3D printing market. So we have smarter printers. So it's not just relying on G code.
Right.
It's using more sensors and changing stuff in real time. So like you said, right? We're just making the G code explode. Bigger and bigger, bigger G code. But what if like this integration of the temperature changing is not present in the G code? Well,
Right.
we'll use sensors, we make it smarter. It's more of something that's in the firmware. You're saying, hey, I'm using, this brand PLA.
Right.
And then it has a certain instructions on how that should be printed.
Mhm. And
And
on
then
that printer too.
on that printer,
Yeah.
and then it will change the temperature or whatever else it has to in real time.
Right.
So it's a little smarter.
Mm.
Or using sensors um, to more precisely understand how much it's actually extruding. So
Right.
it's more precise with the extrusion, or it can update, change in real time to make sure
Mhm.
it's extruding enough. There's all these little things, sensors and stuff like we built in more. So it's
Right.
not just relying off code, it's relying off sensors in real time to change stuff in real time.
Mm. Catch trends as things
Catch
happen,
trends.
like
Yeah.
maybe you realize if the feed rate starts, trending in one direction, like, is my nozzle breaking
Yeah.
down? Is
Well,
like,
even
are my
the
heaters
strain
wearing
the
out?
strain gauges in these nozzles,
Mm.
you should be able to detect, or you could set it up so that you could detect
Right.
how much pressure you're actually pushing through the nozzle. So
Mhm.
we should actually be measuring pressure through the nozzle
Yeah.
and have that almost be a parameter,
Mm.
or like trying to maintain a certain pressure, or
Right.
I'm at the end of a stop. I want to decrease the pressure and make sure I don't have a lot of back pressure and have
Mm.
stringing. So if we were reading that in real time, right, then we could adjust the temperature, or we could adjust the flow
Yeah.
or whatever to try to also maintain that or change it in a specific way.
Yeah. But it's awesome, dude. I think that's the way of the future, and I think we need these companies making these machines to start focusing on some longer term things like that. And I'll share this just to nerd out because I did see
Oh, I
this.
haven't seen this picture. Yes,
Oh,
you
yes.
can see the induction coils at the bottom.
It's beautiful, right?
Oh,
Like
they
what
do have a little
they've
fan in there.
yeah.
So I don't remember what it stands for, but the DX part is actually for the drive, the extruding drive.
Mm,
Oh wow. Am I crazy? Do those
beautiful.
gears look 3D printed?
They they do look maybe like they're oiled up, but I guess there it could be, right?
I
Because
would
it's not affecting the filament.
I would hope not, though.
directly.
They want something more wear resistant and hold up.
Right.
Is
Right.
that a spring in the middle?
Yep.
Oh, I guess
Looks like
that's
maybe
a
to catch
tensioner.
the yeah.
Yeah. Oh, that's a cool picture.
Yeah. Big shout out to Adam at Vector 3D for
Oh, yeah,
sharing that.
Vector 3D, yeah. And it's great 'cause the everything's 3D printed. The whole casing and stuff is
I know. I know.
SLS printed, I think.
I think so too. It looks like that. I call it HP, but it doesn't necessarily need to be HP. Just
Yeah, probably maybe MJF.
yeah. Yeah. It's cool. But like a company needs to be focused on long-term stuff for this kind of thing to happen. It's just otherwise it's not going to happen. And we'll keep reusing the same old stuff and calling it smarter when it's really not smarter.
Exactly. Yeah, in the age of
Cool.
robotics, this is so the 3D printers right now are just so early.
And it's interesting too because with all the humanoid robotic stuff happening, you're seeing the form factor of all these things reducing. As you see, like there's a few different companies out there that have them, and you're seeing them all kind of slim down, and the mechanics, being brought in and reduced in size and consolidated.
Yep.
This to me looks like it's following the same trend that we're seeing in those innovators. So that excites me.
Mm-hmm.